In this video, I'm going to talk about the concept of leftist tree. Okay, leftist tree is the topic. So, leftist tree. Before going into the topic of leftist tree, we need to know these two concepts. One is the concept of binary tree, and the other one is complete binary tree. Complete binary tree, and we have something called as extended binary tree. Okay, what happens here is there is a node and that node may not have any child nodes, or there is a node which has one child node, or there is a node which has two child nodes. These are called as binary trees. So how do you define a binary tree? A node can have up to maximum of two child nodes. That is called as binary tree. Now, what is complete binary tree? Complete binary tree means a node has to have two child nodes. It has to have two child nodes. So, this is a binary tree. This third one is a binary tree, but it is not a complete binary tree because it is not having any child nodes. Whereas this one, okay, see here, this is a complete binary tree. Why? Because this parent is having these two child nodes. Okay, likewise, what is extended binary tree? See this, uh, something like this. Okay, so this is the node, main node. It has two child nodes, whereas you look at this one, it is only having the left child. The right child is missing, as you can see. So what you're supposed to do is you add some extra nodes in order to make it as the complete binary tree. So here also I am adding. Okay, extended binary tree is a combination of this already existing binary tree and the nodes that you add extra in order to make it as a complete binary tree. Okay, so these are called as these nodes that are already present. They are called as internal nodes. They are called as internal nodes, and the nodes that you have added extra, okay, these are represented as like a square, because you have to identify which are not actually the part of a binary tree. That's why I am representing it as a square. So this becomes the external node. Okay, so a extended binary tree is a combination of internal nodes as well as the combination of external nodes. So I hope these three concepts are clear. What is a binary tree? A tree which can have a node in which the node will have at most two child nodes. Complete binary tree, a node will have two child nodes. Extended binary tree, if a node does not have two child nodes, then you add an extra link in order to make it as two. Okay, so the existing ones are called as internal nodes, and the nodes that you have added extra, they are represented as square with the dotted lines. So not dotted lines are not required, but the shape is represented in the form of a square. That is called as an extended binary tree. I hope this concept is very clear. Now we will come to the actual concept, that is your leftist tree. Okay, so let me take a pen, 1 second. Okay, so let me take the concept here, leftist tree. Okay, leftist tree. Okay, leftist tree is an extension. It is an extension of extended binary tree. It is an extension of extended binary tree. Let me tell you how this works and what it is and all of that. Okay, so here first of all there are two types. One is height based leftist tree and the other one is weight based leftist tree. Okay, so here this height based leftist tree that you have, that itself, this height based leftist tree is generally referred to as leftist tree. Okay, so how this works, let me tell you how this works. Okay, in this, okay, So I hope you have understood the definition, what is a leftist tree. Okay, it is an extension, and how this works, let me show it to you, with the help of an example. Okay, see here, I have a tree like this. I have a tree like this. I'll add this extra ones to make it as a complete binary tree. Okay, now what happens is, okay, in leftist tree also we need to know something that is very very important called as S of x, or it is also called as shortest of x. What does this mean? See here, every tree will have some value associated with it, like a weight. Here what happens is, what is that S of x is? Okay, this S of x can be defined as the number of nodes from a given node to the external. Okay, so for example, let me write the S of x for this. See, if I start from here, okay, if I start from here, from this node, how many how many nodes do I travel to? So if I want to reach from this node, let me give the names. If I want to travel from A, B and C, if I want to travel from B to the most nearest external node, how many nodes do I have to cross? I have to just cross one. See here, for example, if I want to find the S of x of A, S of A here, okay, S of A, the shortest. Now you see, if I want to reach from, I will use a different color. If I want to reach from A to this external node, so I will have to go from here to here. Okay, so this node I will check, from here I will go to this node, and then I will reach here. So how many nodes am I actually crossing? So I am crossing, 1 and 2. So I am taking this and this into consideration. So S of A is 2. Likewise, let me show you one more example. Okay, see here. This is 5. This is 9. This is 8. And this is 12. And let me give this one as 10. Okay, this one is 20 and 18. Okay, and let me keep it like this. Now you see, I have to first make this into a complete binary tree. So how do I do that? So I will have to check if every node is having exactly 2 child nodes. So this one is not having, so I'm adding 1. This one is not having, so I'm adding 1. This one is not having, so I'm going to add. This one is not having, so I'm going to add like this. And for this one also I'm going to add. So it's right side, so like this. Now you have to find the S, or that is the shortest of a given node. So for 20, okay, to reach from here to 20, I just have to go through only one node, correct? So it will be like that. From 12, for 12, see very carefully, for 12 I have to go from 20 to 12, or in the either side I can go from 18 to 12. So 18 will be 1 and to 12 it will be 2. So this will become 2. Okay. Likewise you can do for the others also. See for 18, okay, 18 I will reach, how many number of nodes I need? I need only this one, because then if I cross this, immediately I will reach the the external node. But what about here? Let me show it with the different color. Okay, See, let me take this part. This part. See very carefully. 8 child, okay, 8 is child is 110, the other one is not present, so we have drawn an external node over there. Now you have to identify the S of 8. What is the shortest way for 8 to reach to the external node? See, one way is I can go from here, and then I can go from here, then I can go to here, or else there is one more also. You have to consider the shortest possible way to reach. If there are two ways for a node to reach the external node, so I could have reached from here also. I can go from 10 and then reach 8, but then the S of x would become 2. Whereas in the other side over here, I just need only this place. See, I am directly reaching 8, so I will only need 1. So what I will do is I will take S of 8 as 1. Are you understanding? So what you're supposed to do is you have to find the shortest way for a node to reach from the external node to itself. That is what the shortest is. See, we have a problem over here. Okay, let me show you that problem. Okay, so here they have asked what is the leftist tree. Give the declaration. I think declaration you can write, but we have to check whether a given tree is a leftist tree or not, and you have to explain your answer also. Okay, define the leftist tree. There's a definition for a leftist tree. The idea is, okay, in leftist tree also there are two types. Okay, I told you height based also there, weight based also is there, but there is one more point here. See, let me write. Okay, in leftist tree we have something called as, sorry, 1 minute, we have min leftist tree. When you are learning this, keep your model QP answers also with you so that it will be helpful. Okay, min leftist tree. So if I have a tree like this, okay, see, if for a given node and it having its child node, a min leftist tree should have, min means minimum, like small. Okay, so this node, that is your parent node, should have values lesser than your child nodes. So here if you see, the parent node is having the value 4 and its child nodes are having the values 8 and 10. So this can be considered as a min leftist tree. There is also max leftist tree. Max leftist tree, where your parent node should have greater value than the child nodes. It should have greater value than the child nodes. So when they ask you to define the leftist tree, you can define the min and the max leftist tree. So how would you say? You can say that a given node, okay, it should have, if it is a min one, then its value should be smaller than the child nodes. If it is a max, then its value should be greater than the child nodes. That is what min and max leftist tree is. Okay, and the next part is you have to identify whether a given binary tree is a leftist tree or not. So how do we do this? Let me try to do it here itself. I don't know if I will be able to, but let me try. See here, I will do for one of them. Then you can see the model question paper answers, and then you can refer. So what you're supposed to do is, okay, when you have a question like this, how do we check if a binary tree is a leftist tree? There is one condition, okay. The condition goes like this. Its shortest of left child should be, shortest of the left child should be greater than or equal to the shortest of your right child. Okay, remember this condition. Let me talk about this condition. First, what we will do is, when you get a tree like this, find out its shortest. That means find out how many nodes does it have to cross in order to reach the external node. So for this one, let me first draw the external node. Okay, I'll draw for this one. So for this we need two external nodes. For this one we need two external nodes. Here also. So here and here and here. See here. For 9, okay. So for 9, if I want to reach 9, okay, from the external node, I just have to cross 1. Here also it would be 1. Here it would be 2 because it has to either go from 9 and then reach 5 or it can go from 13 and reach 5. Okay, so for 40 it is 1, 90 it is 1, 20 it is 2. Okay, so for 8 you see now. Okay, 8. See, if I want to reach from the left child, so 8's left child. So I can go from 40 then to 20 and then I can reach 8. If I do that, s of x becomes 3. But if I go from the right child part of 8, then I need to travel from 25 and then I will reach 8. So I told you that you have to find the shortest possible, you have to reach your node by taking very less number of nodes. Okay. So this one will be considered, this part will be considered. Likewise here also. Okay. So this one will have, see, for this one, okay, so here it will be 8 then 25, so it can, so for 4 it can go from 9 5 and then reach 4, or from 13 5 then reach 4, or go from 40 20 and 2 and then reach 4, or you can go from the other side. Okay, so you can go from here for example, so from 25, okay, 25 it is 1 2 and this will become 3. This is how you will get the answer. But the thing is, okay, once you have done this calculation, you have to check, this is where you will actually check if a tree is a leftist tree or not. Now what happens is, you have to take this condition into consideration for each of the subtrees that you have. So what is the condition? Shortest of the left child should be greater than or equal to shortest of the right child. For example, if I, one minute, see, I'll take this part. So I'll take this one. I'll take, why is it not moving? This one. So 5 is its parent. Now you have to check the shortest of the left child. Shortest of the left child is 1 and shortest of the right child is 1. So what is the condition? Shortest of the left child should be greater than or equal to 2. So it is not greater than, but it is equal to 2. So it will satisfy. Okay. Now come to the next one. So for this tree, so 20 is the parent. Its child nodes are 40 and 90. So 40 is the S of x is 1. Here also it is 1. So this is also okay. Let us come to this part where 8 is the parent. So 8 is the parent. So its left child is having the S of x as 2 and its right child is having the S of x as 1. So it is still following this condition because S of left child is greater than or equal to 2. So 2 is greater than or equal to 1. Likewise, you will come to this node. This is 2. This is 2. So 2 is greater than or equal to 2. So this, you can say that the first tree is a leftist tree. Okay. Likewise, you will have to do for the next one also. I'll do for one part. See here. So first you have to draw the external nodes to the tree if it is required. Then you have to identify its shortest. Okay. So for this one it is 1. For this one it is 1. This one is 2. Okay. And for this one it is 3. Likewise, here we need 1. Here we need 2. Likewise, here also 2 and here also 2. Like this. Now, for 10 it is 1. But for 5, see here. For 5, One way is I can go through its left child. So I have to go from 10 and reach the external node. But if I see the right child, I can directly reach from 5 to the external node just by crossing 5. So 1. Okay, so this is how I will do. Now I'll show you a condition where a binary tree is not a leftist tree. Okay, a binary tree is not a leftist tree. Let me draw it over here. See this, okay. So here, circle, 2 nodes, and here 1. Okay, this is your tree. So I will try to complete it by drawing the nodes. And like this. Better to name the nodes. So A, B, C, D, E, and F. Let me write this. Okay, so for this one it is 1, for this one it is 1, for this one it is 2, for F it is 1, for C it is 1 because this is the shortest one that we have, so we can reach directly. And for this one it is 3. Now, can you tell me why this tree is not a leftist tree? Remember? Try to recall and tell me why it is. Till then, let me write the condition. This is shortest of, I don't know why I am writing like this. Shortest of left child should be greater than or equal to shortest of right child. This is a condition. See here in this particular part. See, okay, what is the thing? For a given node, its left child should have greater value of S than the right child. But if you see here, this value is 0 because it's a null, it's an external node. Whereas in the right side, if you see, it is 1. Correct? So you see it is not greater than or equal to the right side. So we can say that this particular tree that you have is not a leftist tree. It is not a leftist tree. This is how you solve to check if a tree is a leftist tree or not. Okay. So you can now, I think you will be able to solve any problem which is given like this to check whether the given binary tree is a leftist tree. How do you do? What you have to do is you have to first take the tree, make it as a complete binary tree. Okay, no, sorry, make it as an extended binary tree by adding those external nodes. After that, write its shortest, that is your distance from the external node to the, from the external node to the given node. If node is having 2 child nodes, and then if it is having 2 child nodes, then you have to take the one which is shorter. Okay, that you have to do. After that, you have to look for that condition. What is the condition? Shortest of left child and shortest of right child should follow this condition. That is, left child should have S value greater than or equal to the right child. If it is true for the entire subtrees, okay, of all the subtrees in the given tree, then you can say that a given binary tree is a leftist tree. I hope you have understood. This is how you will solve these type of questions. Now we have one more extension of this. Okay, let me tell you what this is. Okay, there is something called as, it is called as melding of the leftist tree. See, they will give you the 2 trips. You have to meld them. First of all, what is meant by meld? Meld is basically, it's like merge. It's like putting one into other and making it as one. Like you add, so you see like water and oil, and then you mix vigorously to make it as a combined liquid. So something like that. Here what we have is we meld the 2 binary trees. That means we sort of add them in order to make it as a one complete. It is not complete, one binary tree. That is what is called as melding of a tree. Then very particular, if I have to say, it is melding of the min leftist tree. Melding min leftist tree. That means you will have two trees, you have to meld them to form a single tree. Okay, I hope you remember what is a leftist tree. Leftist tree means min leftist tree. So here your parents node should have lesser value than the child nodes. This is when it is a min leftist tree. Now we have one more problem in the model question paper. I'll take that only and I'll show you how to uh, solve this kind of problems. The problems that will be usually asked is they will tell you define the min leftist tree and you have to meld those two trees. Okay, min leftist tree. Okay, so these are the two trees and you have to merge them. So meld them. Okay, so let me first draw those two trees and then we will try to meld them. Okay, so here it is. Let me draw. So I'll call one as tree A, the other one as tree B. Okay, so this is tree A. This is the problem. 2 is the parent. Its child nodes are 7 and 50. 7 is having left child 11. Its left child 13. 50 is having a left child 80. This is tree 1. Likewise, let's have tree 2, that is tree B. I'll write the nodes 5. From 5 to 9. 9 to 8. 9 to 12. 8 to 10. From here 20, then 18 and 15. This is our tree. Or I think if I draw on this, I think it will become messy. So I'll just take a screenshot of this. Give me a second. Okay, I should have done that earlier. Okay, now I have to meld these two trees. Okay, I know that this is a min leftist tree. How do I know? Because a given node is having lesser value than its child nodes. It is true for all the all the nodes that is present in this tree. And we don't have to worry about finding the shortest because they have already given it in the question. Okay. Now our problem is we have to meld them. Okay, so understand the steps very clearly and learn them. Okay, see here, what we do is in the step number one, okay, in the step number one we find the tree with the smallest root. We find the tree with the smallest root. So see both the trees. This is tree A and this is tree B. Look at both the trees and identify which is having the smallest root. Okay, so 2 and the other one is 5. So obviously we reach to a conclusion that tree A is having the smaller root. Now what you have to do is, okay, what you are supposed to do is, okay, take the right child of this tree which is having the smaller root. Okay, take that. Okay, and write it. Okay, so I'll repeat it once again. You have to find the tree with the smallest root. Find the tree with the smallest root and take its right child. Okay, take its right child. So I've written the right child. And now you try to meld this with the existing other tree. So something like this. So 8, 12, 10, 20, 18 and 50. Okay. So because this is a new, now this is a new subtree, this has become a tree altogether. So I'll call it as tree C. This is still the same, so I'll call it as tree B. Okay. So take the tree with the smallest root. Okay. And its right child should be taken separately, and you have to meld it with the other tree that is given. Now you have this tree C and tree D. Now in this you have to find the tree with the smallest root. So one tree is having the root as 50, the other one is having the root as 5. So obviously I will choose this one. Now take the right side of this. Take the right side of this and melt it with the existing tree. So here let me do it. So tree C will be as it is. So that is 50 and 80. Smallest root was 5. So its right side I will take. So it is 8, 10 and 50. Okay. So this is what I have got. Now check again you have to repeat the same thing. Check the tree with the smallest root. Check the tree with the smallest root. So one is having the root as 50, the other one is having the root as 8. So I will obviously consider this, okay, I'll name it as tree D. So I will take this one. Its right side I have to take. But you see that it is not actually having any right side. So obviously this would be null. This would be null. So I will take that null part from the tree having the shortest root with the existing tree. Like this. So I have tree D over here and the other part, not tree D, this is tree C and this one, the other part is null. Here we will stop because there is nothing to merge now. I mean, we can't find the tree with the smallest root anymore. Okay, so here this is so we have done it 4 times. See here, this one first time, this and this we tried, then we tried with these two, and here. Okay, so you have to do this first. You have to understand this clearly. Okay, so I hope you have understood. Okay, so what you're supposed to do, let me tell again. For a given tree, there will be 2 trees or more than, usually it is 2 trees. We have to meld the 2 trees. What is the step? Take the root of the smallest tree, take its right child and meld it with the other entire tree. Meld means you write it together first. You can't meld it, you write it. Then again do the same thing. Then you will have a tree here. Say for example 50 and 5. Then you will see that 5 is having the smaller root. So what you will do is take its right child and you will try to meld. No. Okay. I mean, yeah. Then you will do the same thing. You have to stop when the other tree becomes null. That means there are no more nodes left. Now we will try to again merge this in order to find the single leftist tree. First you have to divide like this. Then again you have to combine. So how do you combine? What you're supposed to do is, okay, see here. So in this one, okay, we have this part, right? The other one can't be melded, so I will take this one. Okay, in this, what you're supposed to do is take this part, okay. 1 second, just 1 second, okay. Okay, sorry for pausing for a second. Okay, so what we are supposed to do is, once we have done this, we have reached the end. Now we have to again join them. Let me, shorten it or zoom out. Okay. Now what you are supposed to take is, take the last tree, that is your 50 and 80, correct? This is your last tree. Let me use a different color. The last tree you have to take, this one. and go back to the previous merge and see here which part of the tree, okay, ಇದರಲ್ಲಿ ಎರಡರಲ್ಲಿ ಸಣ್ಣದ ರೂಟ್ ಯಾವುದು, ಯು ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ದಿಸ್ ಒನ್, ಕರೆಕ್ಟ್. ಸೊ ಇದರಲ್ಲಿ ನೀವು ನಲ್ಲನ್ನು ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ಪಿಗೆ ತಗೊಂಡು ಹೋಗಿದ್ದೀರಿ, ಅದ್ರ ಯಾವುದನ್ನು ತಗೊಂಡು ಹೋಗ್ಲಿಲ್ಲ ನೋಡಿ, 8, 10 ಮತ್ತೆ 15 ಅನ್ನು, ಅದನ್ನು ಮತ್ತೆ ಈಗ ಎಕ್ಸಿಸ್ಟಿಂಗ್ ಅಲ್ಲಿರುವ ಟ್ರೀ ಅನ್ನು ನೀವು ಮರ್ಜ್ ಮಾಡ್ಬೇಕು, ಮೆಲ್ಡ್ ಮಾಡ್ಬೇಕು. ಅಂದ್ರೆ ಈ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ನೀವು ಯಾವ್ದು ಟ್ರೀ ತಗೊಂಡಿದ್ದೀರಿ ಅದು ಓಕೆ, ಅದು ಮತ್ತೆ ಪ್ರೀವಿಯಸ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ನೀವು ಯಾವ ಪಾರ್ಟ್ ತಗೊಂಡಿದ್ದೀರಿ ನೋಡಿ ಅದ್ರದ್ದು ರೂಟ್ ಅಲ್ಲಿರೋ ಇನ್ನೊಂದು ಸೈಡ್ ಅನ್ನು ಅದನ್ನು ನೀವು ತಗೊಳ್ಬೇಕು. ಸೊ ಹಿಯರ್ ಇಟ್ ವಿಲ್ ಬಿ 8, ಓಕೆ, ಅಂಡ್ 10, ಆಮೇಲೆ 15, ಅದನ್ನು ಇದಕ್ಕೆ ಹೀಗೆ ಮೆಲ್ಡ್ ಮಾಡುದು. Okay, so this you have got, right? So this now you have to go back one step backwards, that is here, and you have to find the tree with the least root. So here this one, and you have to take the part that was not brought to the next step. So we are talking about this part. Okay, so 5 will become the root. one side ಅಲ್ಲಿ ನೀವು 9, 12, 18 ಅನ್ನು ಅಟ್ಯಾಚ್ ಮಾಡಬೇಕು, ಇನ್ನೊಂದರಲ್ಲಿ 8, ಅದು 10, 15 ಅಂತ ಏನಿದೆ ಅದನ್ನು ಅಟ್ಯಾಚ್ ಮಾಡಬೇಕು. ಅದು ಪ್ರಾಬ್ಲಮ್, there is a problem is, okay, in case of leftist tree, if you remember the s of x, okay, your left child, shortest of left child should be greater than or equal to shortest of right child. This you have to follow, correct? So before we meld, we have to check whether these conditions are followed or not. So I'll write directly now. This is 1. This also is 1. This is 1. This is 1. And this is 2. Okay. Let me write for this one. This is 1, 1, 2, and 1. Correct? ಸೊ ಯು ಸಿ ಹಿಯರ್, ಈ ಸಬ್ ಟ್ರೀ ಏನಿದೆ ಅಂದ್ರೆ ಈ ಲೆಫ್ಟ್ ಸೈಡ್ ಏನಿದೆ ಇದ್ರದ್ದು ರೂಟ್ 5, ಅದದು ಲೆಫ್ಟ್ ಚೈಲ್ಡ್ ನೋಡಿ. ಸೊ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಎಸ್ ಆಫ್ ಎಕ್ಸ್ ಎಸ್ 1. ಈಗ ಎಕ್ಸಿಸ್ಟಿಂಗ್ ಅಲ್ಲಿರುವ ಟ್ರೀ ಇದು ಎಸ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ 2. ಸೊ ಇಟ್ ಈಸ್ ನಾಟ್ ಫಾಲೋಯಿಂಗ್ ದಟ್ ಕಂಡೀಷನ್. ನಾನು ಇಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ 9 ಬರ್ದ್ಬಿಟ್ರೆ ಅದು ಎಸ್ ಆಫ್ ಎಕ್ಸ್ ಕಂಡೀಷನ್ ಅನ್ನು ಫಾಲೋ ಮಾಡೋದಿಲ್ಲ. ಸೊ ವಾಟ್ ಯು ಆರ್ ಸಪೋಸ್ ಟು ಡೂ ಇನ್ ಸಚ್ ಕೇಸಸ್, ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಂಟರ್ಚೇಂಜ್ ಮಾಡ್ಬಿಡಿ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಂಟರ್ಚೇಂಜ್ ಮಾಡ್ಬಿಡ್ಬೇಕು. So it will go like this. See, instead of directly placing the value of 9 as a left child of 5, you have to check whether this 9 that subtree and this exists that we just created, this 8 one, is following this condition. This condition is very important. It does not follow, so we will interchange. So this becomes 8, this becomes 10. Okay, this is 15, then 8 into 50, then 80, then this is 9, then 12, and then 20, and then 80. Next. Okay, so what we have done? We have merged. Now this will become the new tree. Go one step backwards. We are coming here. And you have to find in this which is having the smallest root, and you have to meld its left side to the tree that we have just created. ಈಗ ಪ್ರಾಬ್ಲಮ್ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, ಓಕೆ, ಈಗ ನೋಡಿ ಇಲ್ಲಿ ಒಂದು ಚೇಂಜಸ್ ಮಾಡಬೇಕು. ಏನಂತ ಹೇಳಿದ್ರೆ ನೀವು ನೋಟ್ಸ್ ಅನ್ನು ಇಂಟರ್ಚೇಂಜ್ ಮಾಡಿದ್ದೀರಿ. ಸಿ 9 was previously towards the left, correct? Now I have interchanged it to the right because it was not following that condition. So ನೀವೀಗ ಅದನ್ನು ಇಂಟರ್ಚೇಂಜ್ ಮಾಡುವಾಗ ನೀವಲ್ಲಿ ಲೈನ್ ಹಾಕುವಾಗ ಡಾಟೆಡ್ ಲೈನ್ಸ್ ಹಾಕಬೇಕು ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ದ ನಾರ್ಮಲ್ ಕನೆಕ್ಟಿಂಗ್ ಲೈನ್ಸ್. ನೆಕ್ಸ್ಟ್ 2, 7, 9, 11, ಅದು 2, 7, 11, 13 ಅಂಡ್ ಈ ಎಕ್ಸಿಸ್ಟಿಂಗ್ ಟ್ರೀ ಅನ್ನು ಇದು ಮರ್ಜ್ ಮಾಡ್ಲಿಕ್ಕೆ ನೋಡ್ರಿ. ಸೊ ಹೌ ಡಸ್ ಇಟ್ ವರ್ಕ್? ಅಗೇನ್ ಯು ಹ್ಯಾವ್ ಟು ಸಿ. ಓಕೆ, ಸೊ ಇದ್ರದ್ದು ನೋಡಿ 1 ಎಸ್, ಇದ್ರದ್ದು 1, ಇದ್ರದ್ದು 1. ಇಲ್ಲಿ ನೋಡುವ, this is 1, So in any case, it is not going to be 1 because this will have the value greater. So what you are supposed to do is, ಇದನ್ನು ನೀವು ರೈಟ್ ಸಬ್ ಟ್ರೀ ಲೆಫ್ಟ್ ಸಬ್ ಟ್ರೀ ಆಗಿ ಮಾಡಬೇಕು. ಈ 2 ಇದು ಲೆಫ್ಟ್ ಸಬ್ ಟ್ರೀ ಆಗಿ ಮಾಡಬೇಕು. ಸೊ something like this. Okay, so you have the existing tree, that is 2. You have the 2 ಆದರೆ ಅದನ್ನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಹಾಕ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ದ ಅದರ್ ಸೈಡ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಲೆಸರ್ ವ್ಯಾಲ್ಯೂ. ಕರೆಕ್ಟ್. ಸೊ ಲೆಫ್ಟ್ ಚೈಲ್ಡ್ ಇಲ್ಲಿ ಏನಿತ್ತು ಅದು ಈ ಸೈಡ್ಗೆ ಬರುವಾಗ ರೈಟ್ ಚೈಲ್ಡ್ ಆಗ್ತದೆ. ಸೊ ಇಲ್ಲಿ 7, 11, 13 ಏನಿತ್ತು, ಸೊ ದ್ಯಾಟ್ ವಿಲ್ ಬಿಕಮ್ your right child, like this, 7, 11 and 13. Whereas this side will be occupied by this part, that is 5, then that 8, 9, 12, 20, 18, 10, 50, 15 and 8. This is how you will get the melded, oh god, what am I writing? Melded leftist tree. Okay, so take one example and try to do this. ಹೀಗೆ ನೀವು ಡಿವೈಡ್ ಮಾಡಬೇಕು ಸ್ಟೆಪ್ಸ್ ಅನ್ನು. ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಫಸ್ಟ್ ನೀವು 2 ಟ್ರೀ ಅನ್ನು ತಗೊಂಡು, ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದ 2 trees, ಯು ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ದ ರೂಟ್ ಆಫ್ ದ ಟ್ರೀ ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಲೆಸರ್ ವ್ಯಾಲ್ಯೂ. ಸೊ ಅದನ್ನು ತಗೊಂಡು ಅದರ ರೈಟ್ ಸೈಡ್ ಅನ್ನು ಮಾತ್ರ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ಪಿಗೆ ತಗೊಂಡು ಹೋಗಿ, ದ ಅದರ್ ಟ್ರೀ ಯು ಕೀಪ್ ಇಟ್ ಆಸ್ ಇಟ್ ಇಸ್. Now this part that you have taken from the previous tree and your other tree, now again you check which is having the smaller root and take the part. Like that you try to do it till one tree becomes null. After you have done that, null anta ಏನಿದೆ ಅದನ್ನು ಬಿಡಿ. ಅದರ ನೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ ಇನ್ನೊಂದಿದೆ ಅಲ್ಲ, ಇನ್ನೊಂದು ಸೈಡ್, ಅದನ್ನು ಮತ್ತೆ ಪ್ರೀವಿಯಸ್ ನೀವು ಮರ್ಜ್ ಮಾಡಿದ್ರಲ್ಲ ಅದರಲ್ಲಿ ನೀವು ಯಾವ ಪಾರ್ಟ್ ಅನ್ನು ಇನ್ಕ್ಲೂಡ್ ಮಾಡಲಿಲ್ಲ ನೋಡಿ, ಅದನ್ನು ನೀವು ಜಾಯಿನ್ ಮಾಡಬೇಕು. ಸೊ ಹಿಯರ್ ಇಫ್ ಯು ಸಿ, I have got 50 and 80 here, that part, and I will go back to the previous step. Here I had selected the this part null, but the other part was not touched, right? So I have to take that part and I have to merge here. Merge in the sense meld. Okay, so I will have to meld, but I have to follow that condition. Okay, that is s of your left child should be greater than or equal to the s of right child. Okay, so here if you see in this one, where is it? Here. So for this one, s is 1, this is also 1, this is also 1, and this is also 1. So either the condition it will follow, so it comes to this. Let me use a different color. It comes to this condition. Now we have to go back one step again. So this is my tree and I will take this much, but here I have not taken the right side, and so this part and this part has to be compared. So while comparing, this does not follow that rule, so I will interchange the nodes. Like that I will go and do till the very end. This is how you will find the how you will meld the two trees. Okay, so I hope you have understood, and you should be able to do it. Okay, thank you so much.